Dr. Priyansh Chikral, and let's have a small discussion on corneal topography. Now, cornea is most powerful refractive element of the eye, contributing about 70% of the refractive power of eye. Considering the total refractive power of eye to be 60 diopter, the contribution of cornea comes out approximately 43 diopters. Now, corneal topography is a study of the shape of the corneal surface, and since a small change in shape of the corneal surface has a lot of impact on the image formed on the retina, so it is a very crucial element in determining the refractive status as well as planning the refractive surgery. Now, coming out to the optical system of eye, here in the diagram we can see there are various axes and various angles and various points. Now when we have a look at the eye, EP stands for the pupillary center, and it also stands for the entrance of the pupil. So there is a axis known as PA, which is pupillary axis. Hence, the pupillary axis is the axis which connects center of the pupil to the center of anterior curved surface of the cornea. Now here a term you can see there is a term LOS, which means line of sight, and there is a point which is N. N stands for the nodal point of eye. So nodal point of eye is that point from which the ray passing through the nodal point will not get refractive. So for our purpose, there is a optical axis. What is optical axis? It is the axis which connects all the refractive surfaces from the center of the all the refractive surfaces. So center of anterior surface of cornea, center of posterior surface of cornea, center of anterior surface of lens, and center of posterior surface of lens. So the line joining all these 4 points is known as optical axis. Now there is a axis which is known as VA. It is visual axis. Visual axis is that axis which joins the fovea to the nodal point of eye and exits through the cornea. The important thing over here is that it is not necessary that that the visual axis passes through the center of cornea. It may also be displaced. So apex of cornea does not necessarily correlate with the visual axis, as we will see in the later talks about the keratoconus. Now coming on to few values of the normal cornea. The normal cornea is prolate shaped. Now what is meant by prolate shape is that the center of the cornea is steep while the periphery of the cornea is flatter as compared to the center of cornea. So the center of cornea is basically elliptical and has a horizontal diameter of average horizontal diameter of 12.6 millimeter, while average vertical diameter is approximately 11.7 mm. Posterior surface of cornea is circular, having an average diameter of 11.5. The thickness of cornea varies from center to the limbus. Center is the thinnest, while the limbus is the thickest. Center of cornea is approximately 0.52 mm. Periphery accounting to approximately 0.8 mm, and the limbus it converts to approximately 1 to 1.2 millimeter. Now, as we have two surfaces of cornea, so we will have two radius of curvature. So anterior radius of curvature is 7.8 mm, while the posterior radius of curvature is approximately 6.5 mm. Coming on to zones of cornea. There are 4 zones of cornea. Number 1, central zone. Number 2 is paracentral zone. Number 3 is peripheral zone, and number 4 is limbal zone. Central zone is also known as apical zone and is approximately 4 mm in diameter. And it is usually spherical in shape. Paracentral zone is 4 to 8 mm in diameter and it is flatter than the central zone. Now paracentral as well as central zone both constitute optical zone. Now coming on to peripheral zone. Peripheral zone is 8 to 11 mm in diameter, is from 8 to 11 mm, and it is a zone where normal cornea flattens the most and becomes aspheric. And fourth is the limbal zone. Now having a look at various corneal topography techniques, we come across number one, keratometry. Number two is based methods, including placido disc and video keratoscopy. Number three is slit scanning system, which includes Orbiscan. And number four is shine plug imaging, which includes pentacam, Sirius, and Galilei. Now, what is the need of topography? As we have discussed that topography can also be done by keratometer, but there is a major disadvantage. What is it? Keratometer measures only the anterior radius of curvature of cornea along the two principal meridia at points located 3 to 3.2 mm apart on the paracentral region, assuming the cornea is a perfect sphere, while the normal cornea itself is aspheric. So it changes its radius of curvature at every point. So this is the biggest assumption and biggest drawback of keratometry. Moreover, it is not sufficient in cases of refractive surgery and diagnosing the corneal ectasias, because in these two cases we need accurate analysis of whole of the anterior surface as well as the posterior surface. Now, placido disc based devices. The principle is that the cornea works like a convex mirror and the reflected images are viewed directly or captured or analyzed. Now, the shape and orientation of the Myers give an idea about the shape of the cornea. Difference in the distance between the Myers give an idea about the steepening and flattening. What does this mean? It means that the place where the Myers are very close to each other, it is steeper, while the place where they are distant, somewhat distant apart, then it means it is flattened. Video keratoscope is a backlit placido disc and camera respectively to image the cornea instead of indirect illumination and the observer's eyes. It measures all the three parts of cornea, which are central, peripheral, paracentral, and peripheral cornea. It is basically of two types. Number one is large cone, and number two is small cone. Small cone provides more complete coverage of the cornea and avoidance of data loss due to varying nasal bridge anatomy. Slit system. Slit scanning and triangulation are used to derive the actual spatial locations of thousands of the points on the surface. A series of slit lamp beams are compiled across the cornea to create a profile of the cornea. Now coming on to shine plug imaging. What shine plug law says is to get a higher depth of focus, move the three planes, provided that the picture plane, the objective plane, and the film plane have to cut each other in one line or one point of the intersection. Now, what does it mean? Like you can see in the image, there are three planes. Number one is picture plane, depicted in blue. Number two is objective plane, depicted in green, and number three is film. So the point of intersection of these three planes is also depicted. Now the image will be taken on the film plane, while the object is on the picture or focal plane. So we can see the relation here. Now coming on to pentacam, our main topic of discussion. What is the principle? To calculate the refractive power of a spherical refractive surface, the equation used is power is equal to n1 minus n2 divided by r. Now here n1 is refractive index of the spherical surface. Here it is cornea. N2 is the refractive index of air in front of cornea, which is equal to 0.33751. Okay, and R is the radius of curvature of refractive spherical surface, which is supposed to be the surface of cornea. It is approximately 7.5 mm. So putting all these values in the formula, we will get approximately 45 diopter at all the points. Now there are two images in this slide. The image on the right side depicts that all the rays coming from a point are focused on a same point, that is its focus point. While on the left image we can see that the rays which are peripheral are focused earlier, while the rays which are towards the center are focused more distant, that is at the focus point. So what we can say is that the right image is of cornea. Why? Because it is a aspheric structure which focuses each and every ray of coming to the eye at a single point. That's why it is of cornea. Now, what are the methods of measurement? There are basically two methods of measurement. Number one is sagittal method and number two is tangential method. What is sagittal method? To measure the refractive power of at point A, to a tangent drawn on the surface of the cornea at that point, then the normal of tangent is drawn. It intersects with the reference point at B. Now, taking into consideration that the reference axis is the anatomical axis of the cornea, that is, it passes through its apex. Now, namely, the segment AB is the curvature of radius of cornea at point A. So it means that it will give different radius of curvature at different points. Now, how will the map look like? The sagittal map of curvature will look something like this, as shown in the two images. The image on the left side represents the sagittal curvature map of the front, and the image B, image on the right, depicts the sagittal curvature map of the back of cornea. Now, second method, which is tangential or local method. In this, the circles are used tangentially to examine corneal surface at the points to be measured. The radius of best fit tangential circle is considered to be the radius of curvature of cornea. Radii of circles differ according to the surface changes, and geometrically, the specifications of tangent circles are more accurate than the tangent lines. This method can highlight any irregularity in the cornea, whatever small it may be. This is the tangential curvature of the front of the same cornea depicted in the above image. So we can see a lot of difference over here. Now coming on to the reference axis. Basically there are three reference axes. Number one is visual axis, as we discussed earlier, which connects object to the fovea. Number two is video kinetoscope normal, which is also known as VK normal, as shown in the image. And number three is anatomical axis. Okay, the anatomical axis is the true reference axis. Now coming on to the normal cornea pattern. Based on the anterior sagittal curvature map, the normal cornea is symmetric bow tie pattern. Okay, what is meant by symmetric bow tie? See, in the image, the map given is sagittal curvature map of front. So there we can see two lobes, lobe A and lobe B. If the two lobes of the corneal in the corneal topography are equal, it is symmetric bow tie. Now, symmetric bow tie can be horizontal or it can be vertical, based on the astigmatism in the eye. But we can say that it is regular astigmatism. Why? Because lobes A and lobe B are same. Now, in now coming on to a question, that how can we say that that the two sides are equal, because here we don't see any values. So don't ever go on color of the map, always go with the values. Now when we select the values of the mode and magnify the image to 9 mm circle, we will see different circles, as we will see in the later on maps. Now what we will do is that there are few circles. The innermost circle in the corneal topography report depicts 3 mm cornea. Then there is a circle which depicts 5 mm cornea, then 7 mm cornea, and then 9 mm cornea. Now, if considering this magnification will reveal 11 mm cornea as well as 13 mm cornea also. So, so if the point is symmetrical points on the bow tie which lie at 5 mm circle, the difference between the two is less than 1.5 diopter, then it is considered a symmetrical bow tie pattern. There is a very important concept of enantiomorphism. What is enantiomorphism? It is that, like we used to read in chemistry, there are enantiomers. They are mirror images. So similarly, we can see with cornea, the two eyes of same person are very similar and present mirror images of each other. It is useful to decide whether the cornea is normal or not. How? By comparing it with the map of contralateral eye. Now the sum of the angles between the two eyes must always be 180 degree for it to be normal. Okay. Now let's see various topographic shape patterns. Coming on to first pattern. Important note is that all the topographic shape patterns are defined based on the sagittal curvature map of the front. So number one pattern is round, as we can see in the image. In this, the apex lies in the center of the circle. Number two is oval pattern. Here we can see the oval red area which depicts a larger cone. Number three is superior steep. What is superior steep? As in image, you can see there are two lobes, a red lobe on the superior side and a red lobe on the inferior side. Now comparing these two lobes, we can see that the superior lobe is larger while the inferior lobe is smaller. It means that the superior lobe is steeper. So this is known as superior steep pattern. Now contrary to this, it is inferior steep pattern in which the inferior lobe is larger. This pattern is known as irregular pattern. What is irregular pattern? It means there is no defined shape of that pattern. Now coming on to sixth pattern, which is symmetric bow tie. It is already discussed, but important to note is it is indicative of number one, normal astigmatism, and number two, it can also depict symmetric type of keratoconus. Coming on to pattern number 7, which is symmetric bow tie with angulation or skewing between the lobes A and B. It is non-orthogonal astigmatism or lazy 8 pattern, and the angulation is considered to be clinically significant when it exceeds 22 degrees. Now we can see over here in the 3 mm zone, if we take the 43.8 line further, we can easily calculate the axis. How? Because you can observe that the axes are already written in the sides in the side of the map. Okay, this is how we will calculate the angulation between the two axes. If it's clear over here, then we can move to next pattern, which is pattern number 8 or asymmetric bow tie or inferior steep, which is known as APIS. If the difference between the two asymmetric values on the 5 mm central circle is more than 1.5 diopter, it is considered as significant and risky. Now we can see over here is that this is the center of cornea, which is 46.4. Then the circle with 46.3 on one side and 45.2 on another side is 3 mm circle. So the circle outer to this will be 5 mm circle. So if we do consider two symmetrical points, let us consider two symmetrical points to be 45.8 and 47.9 as circled in this image. So the difference comes out to be 2.1. So it is more than 1.5. So it is asymmetric bow tie with inferior steep. Coming on to pattern number 9. Pattern number 9 is almost similar, just the difference is that on the 5 mm central circle which we considered in the above pattern, the difference between the two symmetrical points must be more than 2.5 diopter. Now coming on to pattern number 10. This is very important. The angulation is clinically significant when it is more than 22 degrees. What does it mean? It is asymmetrical bow tie pattern with angulation between the two lobes. Okay, like it is seen in leftmost image. This image, you can see you are able to appreciate the two purple lobes. One is smaller and one is larger. Now apply the same method as applied above with the angulated bow tie in this image. You'll get the degrees. Coming on to 11th pattern, which is butterfly pattern. Butterfly pattern is this. As you are able to appreciate that the red part is almost of a shape of a butterfly. This is known as butterfly pattern. And the next or 12th pattern in this slide is kissing bird pattern or claw pattern. In this, you will be able to see the red area is almost intersecting at the center. This is known as kissing bird pattern or the claw pattern. Coming on to 13th pattern, which is junctional pattern. 14th pattern is spinning face pattern, and it is very risky as it will lead to post-operative ectasias, and it might be an indicator of keratoconus. Now last pattern is pattern number 15, which is Nazi logo pattern. Okay, this is Nazi logo pattern on the rightmost. Now one catch in this is all the named patterns are always very risky patterns, so they are high risk patterns for any refractive surgery. So these patients must not be taken for refractive surgery in any instance.